So in this video, we're going to show you how to solve Norton's equivalent of V of Thevenin, right? So how does a Norton's equivalence work? So a Norton's equivalent, we're going to use, basically we're going to use solve, right, Norton, which is the counterpart to Thevenin, and we're going to use node voltage again, because node voltage is probably the easiest way to solve a problem, okay? So before we opened up a circuit, we had an open circuit calculation here, but in Norton, what you're going to do is you're going to set this, right, to a closed circuit, okay? So now that magical resistor disappears, and when you have I of short circuit. Now, there's several ways to do this. You can use mesh current. I'll use node voltage. And what I'm going to do is I'm simply going to rewrite the circuit just like that, okay? And, you know, by this time, your knowledge of node voltage should already be there, right? So using node voltage at V1, we're going to do this equations, okay? And what we're going to do is, again, you have Kirchhoff's current law, so you'll have I coming in, I going in here. Let's call this I1, I2, I3 drops, and I4 is going to drop this way, okay? So this is our convention, right? We're going to assume this comes in because the direction of the current is the most critical element to solving these problems. Once you understand the direction of the current, problems are real simple. So it's coming in, okay, because obviously current goes from minus to plus, okay? And it's going to come in because we have a directional current here at 2 amps, and we'll write 2 amps here. And now we have a current going out and a current going out, okay? So this is going to be plus minus like that because it's going to drop, okay? This is going to be plus minus here, it's going to drop, and this has to drop this way, right? Okay, so what we want to do is now just say Kirchhoff's current law states sum of the currents coming into the node is positive. So I1 plus I2 minus I3 minus I4 is 0. So what's going to happen is that it's the way you write I1 is what? I1 is plus 10, right, minus the closest sign to the node. So the closest is a minus V1, right? So that's why you have a minus sign here, right? Otherwise you'd have a plus sign. So plus 10 minus V1 over 2. Then you'll have plus, because I2 is coming in, 2 amps, you write a 2, okay? And then you're going to have a plus, right, V1. I'm sorry, you'll have a minus sign here, do here, right? And then you'll have a plus V1 over 20, just like that, okay? And then you have another minus sign coming out this way, minus, and then you'll have V1 over 6, okay? And that's equal to 0. Now, going through the math, I did it slightly kind of, I'm a bit right-handed, so it's a little diagonal. You have to apologize. How do I break this down? 10 divided by 2 is we're going to break this down. I'm sorry, this is going to be a 5 ohm. Let me go back and change this. This is wrong. Okay, let me go back and change all this. This is 5 ohms here. Apologize for the original problem. Please forgive me. So this is a 5. This is a 5. Okay, make sure you make that change. So 10 divided by 5 is 2 minus V1 over 5, just like that, minus V1 over 20, okay, plus 2 minus V1 over 6 is equal to 0. Okay, now how do I break this down? Well, this and this is 4. Okay, so we'll have a 4. 2 plus 2 is 4. You get rid of that. How do you get rid of this V1? How does that work? Well, if you take a calculator, 1 over 5 is 0.20 V1, okay, plus 0.05 V2, okay, and there should be kind of a minus sign out here. So let's deal with the signs first. Make sure the signs are correct, okay. So minus, and a minus 0.167 V1. And this is not a V2. I certainly apologize for that. This should be a V1. Okay. This is a V1. So how are we getting this? 1 over 5 is 0.2, minus sign comes down. 1 over 20 is 0.05, minus sign comes down, right? 1 over 6 is 0.167, minus sign comes down. That will be equal to 0. Okay. Now, a little bit of algebraic manipulation is 0.20 V1 plus 0.05 V1 plus 0.0167 V1 is equal to 4. This flips to this side here, and the negatives cancel out. Okay, that will give you a 0.417 V1 is equal to 4, which gives you V sub Thevenin is equal to 9.6. Now we're solving for I of Norton, right? So how do I get this I of Norton? The I of Norton is going to give you this here. So I of Norton, I of short circuit here, I of SC, right, is equal to what? V times R. V1 times R. Remember that, it's dropping here, okay? So this R is 6 ohms, right? From our from above here. So I of SC is going to be our V1, which is our V sub Thevenin, which is the same thing, right? Which we calculated earlier, I think. We got the calculation, right? No, it's not V sub Thevenin. I'm sorry. I apologize. V1 is 9.6 volts, okay? And from here, you have 9.6 times 6, okay? Which gives you a value of a current. So V is equal to, I'm sorry, this is incorrect. I made a critical mistake here. I apologize. V is equal to IR. So I is V over R is ISC is equal to V over R, right? Which is V1 over 6. Now that makes sense, right? V1 over 6. So V1 over 6 is V1 is 9.6 over 6. So 9.6 over 6 is going to give us a calculation. If you use a calculator, just type in, go in your calculator real quick, and 9.6 divided by 6 gives us 1.6. I of SC is 1.6 amps, right? Which is our I of Norton, just like that. Okay? And that's how we get this.